My name is Jaskarans. My student ID is S4089250, and here it is.
My name is Amira Ahmed, and my student number is S4091985. This is my student ID. And today we'll be walking through our dynamic malware analysis for question 1, assignment 2. To begin, we opened the VM and took a snapshot of our Windows 11 VM. We then opened the VM and ran system info through the command terminal, looking through the OS memory and other information. We then checked through Task Manager, looking through the process that we're running pre-malware. After this, the 4 monitoring tools were opened, these being Procmon, Redshot, System Informer, and Wireshark. We then paused and cleared the log for Procmon, took our first Redshot for a clean registry capture, got Wireshark ready on the Ethernet, and System Informer was also running in the background. We downloaded and extracted our malware file using the password infected, letting it run for 3 to 4 minutes in the background, and then stopping everything, taking our second reg shot.
After the red shot completed, we observed the logs, and it showed that 7 keys were added and 4 were deleted. And the biggest key was a WMI key added under HKLM, which is a known persistence technique. Procmon showed the malware modifying the zone map registry key, disabling auto detect, and enabling proxy bypass, basically lowering network security to allow C2 communication. We verified this directly in registry editor, and it matched.
System Informer showed us the reg CVCS file appearing after execution, which would be usually a normal Windows process. However, it had a non-existent parent process. This means that the malware injected into it then killed itself to hide it itself. Procmon further confirmed the reg CVCS file was a direct child of the malware's PID. This is process hollowing, hiding malicious code inside a trusted Windows binary to dodge detection.
In Wireshark, we looked at HTTP, DNS, and TCP. Mainly in the DNS query, we saw a DNS query to checkip.dyndns.org. The malware this is a malware checking the victim's public IP before C2 connect. We also saw outbound TCP connections to 2 external unknown IPs on ports 80 and 443. These are likely C2 callbacks. In Procmon, filtering by reg SVCS showed it trying to access login data from over 15 browsers, which most of them returned path not found to, but Chrome's was actually read, confirming active credential theft by the malware.
Looking through VirusTotal, we hashed the file with SHA-256 and then ran it through VirusTotal. 35 out of 47 engines flagged it as malicious. The real file was named encoder fallback except.exe, which was identified as Loki and a snake logger, both known for key logging and credential theft. That confirmed everything that we found manually through other forms and analysis.
So basically, the malware injected itself into a trusted process, weakened network security, and then called back to a potential C2 server and stole browser credentials.
We rated this critical severity. Any infected machine should be considered fully compromised. Thank you for watching our demonstration.